Hello guys, this is Virender Singh and welcome back at Mastercam Mill Turn Tutorials and Toolpath series. This is our exercise number 6th part 4th, and in this video we'll learn a lot of new things. Before we have to discuss about what we learned in this video, I would like to show you that what we learned in the previous of 3 parts. If you new on this video, first I would like to suggest you go and learn about the previous 3 video. In the part 1 we show you that all about the simulation, machine simulation of that one component where we are showing you the different number of operations that helps you to understand about that how that part is going to be manufacturing and what different of operations and sequence we are using with the help of left hand spindle, right hand spindle, upper stream as well as the lower stream. After that, in the next one video we show you that how we can create a tool path. After that, in the part 2nd we show you that how we can make a job setup in a mill turn, and that's really important when we are talking about it. And after that, in the last video in the part 3 we show you that how we can create a different number of tool path on the left hand spindle. And after that, I would like to show you in this video how we make a part handling from the left hand spindle to the right hand spindle, as well as I would like to show you that how we can create a different number of multiple tool path on the right hand spindle, turning as well as the milling tool path. So in this right hand spindle you will learn a lot of new tool path, like as a drill, y-axis drill, like as a face drill, that is known as a c-axis drill, c-axis. With the help of c-axis we are going to make a chamfer. With the help of drilling operation we are going to perform a drilling operation, and right at here we are going to make a circular milling operations. So these are the multiple number of operations you will going to be learned in this video. So now we have to start to create these different number of tool path. So first thing that we are going to show you that we have to create a part handling right at here. So for that one purpose we have a wonderful option in the Mastercam that is known as the Poco. Poco is stand for pick off cut off. Once you click on a Poco options, all these things are set perfectly, and that's a really beautiful thing in a Mastercam. And we have to just say okay, because the tool handling position, all these things we all already defining the previously in the job setup. So as you can see here, once I say Poco, so it automatically different number of operations automatically performed, and from the left hand side tool workpiece automatically came in the right hand side. So once successfully that is completed, after that we can get to create the tool path. The first option we have to go or perform that is known as a face operation. For creating a facing operations we are going to use a lower turret, or for creating using the lower turret we have to use select that one option, that is lower turret right hand side. At the time we are using the turret that can be rotated in Z axis, so that time we have to use a direction of tool, that always have to keep in mind, because when the few machines have that turret can rotate in X axis, so that time if we have this direction choose and we want to make from the left side to the right side, so we can use the same tool. But when you have a turret that can rotate in on the Z axis only, so that time you have to keep in mind that you have to choose a tool where the inside is in this direction. These are a really important thing that you always have to keep in mind as per the machine, as per the models and all these things. So you have to select this one, just click on a reference point, define the reference point right at here, and just say okay, the facing operation, all the facing operation just define. After that I have to define the roughing operation with the help of upper turret. So just select this chain, this is my tool, and I am going to create it with the help of upper right hand side turret. So at the condition I have to rotate the B axis. So B axis the rotation is going to be 90, and my tool have to be rotating this direction, that is known as A axis. So that's we have to rotate 180 degree. So that we have to make the depth of rotation, and after that we have to define the reference position. Now have a look, this is my reference position, and after that depth of cut and all these things are the same as the previous. Now I have to add on some the length of this one, so I have to came in a lead in lead out and make a value extending 2 mm extra, and just say okay. So now all these things we successfully created right at here. Now the next one step that we have to perform a tool path for this one is, or this area. So for creating a tool path on this area or this edge, I am going to pick a line and create a line from this point, center of this point to this point, and just say okay. Once I click on and just say okay, we have to came a milling tool path and the tool which I am going to use. And before we are selecting the tool, I have to say analyze entity property and check this line. The total length from here to here and this area, I think it's looking like as a 24.5. It means if we have a tool, the diameter is 30 mm, we can perform and use properly and it will work perfectly. So for that one purpose, we are going to click on a milling tool path. We have to use the tool path that is known as a contour. So just select this chain, just say okay. Tool, the tool which I am going to use at the last tool was 25 mm. So I have to double click on this, make this tool 30 mm, shoulder length and all these 30 mm, just say next. And I can modify this name is also 30 mm and just finish it. Once I select and define all these things, after that the new thing that is add on in a mill turn, that is known as a setup. So I have to click on a setup and the option which I am going to use, that things Mastercam automatically analyze, and that's the beauty of that software. So you have to define the y-axis cross, and now we have to define the upper stream right hand spindle. So you have to click on this cut parameter, all these things are same. You have to come in a linking parameter, make all the parameter incremental and just say okay. So once I define the tool path, my tool path is going to be created, but it's going created right at here. So again I have to came in a parameter, came in lead in, lead out, both close this, both of these, make it on, make it 60% and same copy right at here. In cut parameter I have to just say compensation should going to be off and click on OK. Now have a look. The tool is going to came from the upper side, complete this tool path outside and just up. Now once this side tool path is going to be created, after that I have to create a tool path in the bottom area or back side. So for that one purpose I have to click on tool path transform, click on contour, rotary tool paths, rotate, number of rotation 1, the angle of rotation 180 degree and just say okay. So now backside toolpath automatically created. That's the beauty of Mastercam. Now after creating of that one toolpath, I have to create a toolpath for these holes. So I have to check what is the diameter of these holes. So diameter of these holes are 5 mm. So I am going to create a toolpath with the help of a drill. I have to define the tool hole of both these area. So this is my first hole, this is my second hole. If you are facing an issue when the selection, you have to just click on this. Now these are the both holes. I have to just say okay, select a tool. I have to say selection of tool. Here you have different number of tools. You can just came and select a 5 mm diameter of drill tool, and you have to came on a setup. Once you came on a setup, you have to select a proper tool for the drilling purpose. So that tool is same like as a CXS drill. So you have to click on it and make a create a tool path on a right hand side with the help of upper stream, and the tool is y-axis cross. The cutting parameter and linking parameter, all these parameters are the same like as. So we make nothing changes, make any changes and just say okay. So now as you see, so that's now blunder is going to be started right at here. Tool is going to be entered from the back side, and that is going to be make an issue. So that if you facing an issue on this case, so what you can do, the easy option I would like to suggest, you have to click on a geometry, just delete this, and you can select both of these geometry, and you are going to be get a solution. So now I make a tool path, and that is going to be tool is come from this one direction and make first, and now complete. So now the important thing is we have to again came in a parameter, and we have to define the depth of these holes. So this is depth, make things in incremental, retract value 2 mm and clearance value is 10 mm, and just say okay. So now still we are still facing some issue on this condition. These tools came from the bottom side and nothing is going to be fixed. So that's a main issue I am going to facing a lot of times. Now we have to understand about that, how we can solve that error. When you are facing any issue, so that's the time of learning in a detail. So now we have to understand how we can check out the different thing and how we can solve this issue. So for solving that issue, we have to again came in a parameter, just click on this, deselect, make this selection as a solid hole, okay, and regenerate this toolpath. Once I regenerate this toolpath, tool is came from a proper direction. I have to came in a parameter, in a linking parameter I have to just say this is my top of the stock absolute depth and just say okay. But still our tool is came from the back side. I have to delete this tool path completely. Again came to the drilling, again select this properly, both of solid hole, just select the tool and just say for example first time I am just showing a plane rotation and just say okay. When I define the plane rotation, so that time plane rotation is not properly, I just say align with the machine. So let's see, not working, drive from machine, so it's work properly. Drive with machine, it's a really good option, and when you are using that option, it means software automatically have to detect as per the whole profile, it automatically detect which plane we have to define, and that's a really amazing and good parameter when we are talking about the Mill Turn module. And that I make the changes that we have to do the toolpath on the right hand side, so I just define it, that all these things are successfully defining, and now I would like to add on the clearance value 10 mm extra from this area and just say okay. Now have a look, all these things we are successfully defining right at here, and this is my complete toolpath for the upper side. If you want to make the same toolpath at the lower side, what I have to do, I can make a same thing, toolpath rotation, select the drilling operation, rotate this toolpath, the angle is 180, total number of rotation is 1, and just say okay. So this toolpath is successfully rotated in the back side. Now I have to going to show you that how we can create a toolpath for the front face or right hand side, this one face. So for creating this toolpath, first toolpath I am going to show you that this is a drilling operation. So for creating this drilling operation, again I have to going to create a drill. Just click Ctrl and Shift, select these also, all holes going to select at a single time and just say okay. I have to click on tool, the tool is 5 mm diameter. In a setup I have to say the setup which I am going to use is a C-axis face drill with the help of upper stream on the right hand side. I have to came in cutting parameter. I have to define the depth of cut for this hole, so this I am going to define. In the linking parameter we have multiple number of options, but I just say make it for the now I make it default, and now that toolpath is successfully created. Once this toolpath is successfully created, I have to make some modifications. In the modification I have to make the modification in the retract value, it's going to be changes as 2 mm, and now I have to make the clearance value changes, it's 20 mm. So as you can see here, this is a perfect toolpath for the face drilling operation. Once I successfully create a face drilling operations, again I have to create the toolpath for this drilling operation. I have to choose the diameter of this tool, and this diameter of this tool is 14 mm. So for that one purpose, again I have to choose the tool for that one area. So I have to came in here, click on a drill, just click on it, okay, tool, select tool library, and the tool diameter it is 14 mm, and just say 14 mm, double click on it. I have to click on a setup, I have to use again C-axis face drill, I have to click on the right hand side, the depth of cut, all these things. In the linking parameter I don't have to just say define anything and just say okay. Now have a look. As you can see, toolpath is going to be successfully created till this point. If you want to make some extra distance, so at that point we have to came in a parameter, just say click on it and make extra 4 mm distance and just say okay. Now have a look. This exercise is going to be little extra in length, so all these things, the operation is going to be successfully created right at here. Once that's successfully created, after that I have to create a tool path on this one area, and I am going to show you and create a tool path that is known as a circular milling. Before we start to create this tool path, I have to check or analyze the edge of this portion. So the edge of this portion on radius is 4 mm. So I am going to create a tool path of that is known as a bull nose. So for creating the bull nose tool path, I have to came in a milling. I have to click here helix bow tool path, click on this edge, just say OK, select a tool, and then I have to select a tool. This is a bull nose tool. I have to choose a 10 mm of tool with the help of R2 radius or 12 mm of tool with R2 radius. In a setup, again I have to say y-axis face on the right hand side, cutting parameter, wall and floor should be 0 0. In a linking parameter, pitch value is 1 mm. In a linking parameter, I have to say depth, top of the stock, just say OK. So that's the beauty of these tool paths. Have a look. So once I define and create this tool path in a perfect and a proper way, after that I have to create a tool path for both of these edges, and for that one purpose I am going to show you create a tool path that is known as chamfer mill. So for create a tool path of the chamfer mill, I am going to select a proper tool path which is known as a model chamfer, because we have a solid model. So for that one purpose I am going to select a new tool which is known as a 10 mm. For example, I am going to choose the tool which is a 10 mm of chamfer mill. I have to again came in a setup. I have to choose a y-axis face in a cut parameter. I have to came in a cut parameter, and the edge I have to define. The edge I am always defining this one is, and I hope you guys have idea about the chamfer mill. You have to define the bottom extra clearance is 1 mm, and nothing we have to define. Once I create a tool path, if it is not going to be visible, you have to came in a parameter. You have to check on a setup. We have to make a tool path on the right hand side with the help of upper stream. So have a look. This is a proper tool path. Now I have to add one extra thing that is known as the lead in lead out. I have to click on this, make it at a 10 mm, make it at a 10 mm, and make it at a 90, and just transform this. Now have a look of this tool path. That's all things are going to be handled perfectly. Once I create this tool path successfully, I have to copy this tool path and paste. Click on a geometry, rechain all, and select the bottom edge of this tool model and just generate this tool path. So now as you can see here, all the tool paths are successfully created on the left hand side as well as the right hand side. And now I would like to show you all the tool path in a proper way and synchronization, and that's really important. So now I would like to show you how we can make a synchronization for the left hand and right hand spindle as well as all these things. So for that one purpose, I have to click on this all the tool path, and just we have to say G1. Once I click on a G1, now my new window is going to be open, and I have to say expand all operations. Once I expand all these operations, so this is the last operation till here. After completing of this operation, I would like to say that can be my turret can have to going on a reference position. So for that one purpose, okay, after that I am going to create this from this to this. So this is synchronization right at here. So after that my turret park have to going to synchronize, turret have to going on a parking position. After the turret parking position, I call for the tool point. After all the tool point, the turret park and all this going to happening successfully. Once all these things successfully happening, I have to call again the turret park on a reference position. Once that's successfully done, after that I have to call a face operation. Once facing operation successfully done, I have to call the roughing operations and save this and just say launch. So all these things are very important when we are talking about the mill turn, because synchronization is a very important factor at the point. Now I have to make speed a little high and just play this. Face, drill, groove. Okay, this accident is happening due to the less of length of the tool. And now there is one more accident is happening right at here. and this is one reason behind that. I would like to also change this one also. So there are the two issues are happening in the contour operation. There is one issue, and the second issue was when we make a parting tool path or a finishing tool path. So I have to make so this was facing. After the facing, this is going a finishing after. So I make some changes for the parting tool operation. So we have to make some changes right at here. So I have to again just close it. The first thing is I have to make the modification, that is in the contour operation. In the contour operation or dynamic milling operation, I have to choose the tool, double click on this tool and make some extra length of this 120 mm and just finish. And after that I have to keep in a holder, make it extra approx 100 mm, just say okay and update it. After that, the second thing, I have to make the changes in the finishing operation. In the finishing operation, the tool I am going to choose, make it 11 number and just say okay. And now I have to click on it because there was some issue was happening. Just click on this, so it is going to be recalculating all the operations and close all children parts, recalculating these things. Just say okay, just say okay and G1. Just select all these operations and just press G1. So once I press G1, so I make both of the modifications right at here, and I would like to show you now. Just let's open. This video is going very large in size, but if a person who watch this video and learn about all these things, I'm sure that person will going to be expert in a mill turn module. And if a person who is watching till this time, I would like to suggest you and request you, please just comment that you are till watching this video. So now we have to make again machine simulation. I make a little high speed for that one machine simulation. So this is the facing, roughing. I have to just off the machine housing. Of finishing, grooving. Now there is no attack is here, and this is parting happening perfectly with the independent tool. That issue was because the tool number was same in a one number, that was tool number on one number, and the parting tool was on the same number, and the finishing tool both are the same number. So that's why that was happening. After that I have to take all these operations on the right hand spindle, a face, OD, that one milling tool path, the C drilling tool path, face drilling operation, a center drilling operation. Once my center drilling operation successfully completed, after that we have to make this one circular milling operations, and after that model chamfer for bore op areas. So I hope you guys get understand about this and get learn a lot of new thing in this video. So thank you so much for watching this video, and if you have some doubt or issue, you can just go and comment us on a comment section. Hope you guys learn of new things. Keep learning, keep growing.